Uh, I want to talk about testing, and it's difficult to talk about testing. This is a conference about testing, and every talk is going to be about testing to some degree, but it's really hard to talk about testing, as everyone who's ever tried to talk about testing knows, because you try to talk about testing, and you want to get into the reality and the details of it, but then if you really want to get into the reality of details of it, it sounds like this. It sounds like saying like, so then I was in this field, right? And I had typed an A, B, Z, okay, follow me on this, but I didn't capitalize the A. So then I clicked off the field and on the field again, and I don't know if that made a difference. And I moved the mouse a little bit. That might have made a difference, but I don't know. And then I had TweetDeck up, and I'm like, why should I shut that down before I started testing? So maybe that was involved, but I don't know. I didn't reproduce that. And you can talk about testing, but you'll be spending 30 seconds for every 1 second of real time of testing to actually do a play-by-play of testing. So it's quite challenging to get into what really is testing. And we end up as testers kind of looking at each other, right, DS, and going stuff like, you know what I mean? Like, I tested this. You know what I mean, don't you? You've been there. Yeah, yeah. And if you're two people with any shared experiences, then you go, oh, I probably know what he's talking about. I hope, So I'm trying, in my whole career, what I'm trying to do is two big things. One is to get to the heart of what testing really is, figuring out how to talk about that. Didn't this happen right before, like in Goldfinger, right before everyone was killed? The shields dropped. All right. So, will you be my investors or what? Are you in or out? Anyway, stop making changes while I'm in a train of thought. Okay. So I'm trying to get deep into testing and figure out what is it really, and that means observing it very, very carefully. Anne-Marie Charette and I were at a hotel in Sydney. We were trying to work together. We didn't know what to do. And she said, I haven't tested in a long time. I'm sick of not testing. I said, test right now. And we did a test session, and I took notes. And at the end of it, she said, I don't feel like I was productive. I don't feel like I did anything. And I said, no, you did. Look at all my notes. And then the next day, without her even looking at the product again, she showed up at a meeting with this huge mind map that she did from memory of all the things she learned about that product. It was like a delayed testing reaction. Kind of like, like going, and then nothing happens. And then the next day, there's a red mark on you, like, oh, where did that come from? Delayed reaction. And we even came up with a name for it. We called it analytical lag time. The time between the moment you have an experience and the moment when all these ideas about that experience finally bubble up into your consciousness. So that's a free one for you right now. I'm not originally part of this talk. Analytical lag time. Watch it happen in your own testing. Watch that moment where you're testing and you feel confused and you feel disorganized, but then the next day you come back to testing that thing again and suddenly you're not confused. And if you trace that back, I bet you'll trace it back to that moment when you thought you were confused and you thought you weren't getting anything done, and in retrospect you realize actually a lot of stuff was happening in the midst of all that confusion, and I did learn that, and if I hadn't gone through that, I wouldn't be ready to test today in the way that I am. This talk is based on an article that I wrote for Katrina Clokey because I felt sorry for her, because she was starting a new magazine, and I felt like it was someone who was a friend of mine who was going to have a party and no one was going to show up. So I immediately said, I'll write an article for your magazine. And Aaron Hodder volunteered to help me with it. And I said, what do you want to write about? And he said, how about test cases culture and how test cases are too much the focus of management. Let's do something about that. So I ended up doing a... oh, you know what? If people tweet about me, my darn phone is going to be going crazy because I forgot to put it on silent mode. So what I'm going to do is try to log in to my phone right now to turn the sound off so that it won't be doing stuff whenever it sees me getting tweeted. Okay, good. All right. So I ended up with an article called Testing is Not Test Cases, which would never have been written, and it was really difficult to write because Katrina kept trying to review it and say it's not good enough and send it out to other people to review. But it got better and better, and I'm very proud of it now. Aaron and I think we did a really good job. So that's Testing Trapeze, is that right? Testing Trapeze magazine, the first issue of Testing Trapeze. And there's other issues that are online, but the first issue is online, and you can find this 6,000-word article that will cover material I'm not covering in this talk called Testing is Not Test Cases Toward a Performance Culture. So I wanted to put a link to it, but I forgot, so what, oh yeah, you can tweet a link to that maybe. Thank you, Clarification, who clarifies things. And the link you see here is to the materials I am presenting right now. So if you do that, you'll get to them. Yesterday, Paramala Hariprasad spent 3 hours going over these materials with me. Thank you very much, Perry. It helped me a lot. And here we go. I want to start by showing you some testing. This is brand new material. I collected and recorded and analyzed this material over the past few days with the help of a testing student, Michael Mack, and me. And so I'm going to click on this, and hopefully good things will happen. I want to test oh, there it is. I'm demonstrating the testing of a particular application, which you can download for free. It's from portableapps.com. It's called Focuswriter. It is a tool to help people write novels. And I'm just going to demonstrate testing using one feature of this, which is the scene selector panel, which is the panel that you see before you right here. And I'm going to start this, and this is going at double normal speed. So while I'm talking, it will crank along here. Now, the scene selector panel helps you select and navigate to various scenes within your text document. And it does this via the scene divider pieces of text, which you can define what the scene divider text is. The default is 2 pound signs. And so if you have lots of scenes in your novel and you want to change the order of them, like say you're writing a play or something, and you want to change when certain things happen in your screenplay or whatever, then you can just drag these scenes around once it identifies the scene. So I am testing this as part of this demonstration. I decided to start very simple. The first thing I did is have an empty text. Then I have just one word in the text. And when I have one word and I grab this thing and I try to move it in the scene selector panel, notice that it inserts the scene divider text, even though I didn't ask it to do that. It just decides, oh, there's no scene divider in here. I'll just add that in for you. Well, I didn't know it had that capability. There's also a filter below, and if you type text in, then you can see how the filter works. My charter for this test session is to test the scene selector panel, but there's no documentation for how the scene selector panel is supposed to work. So in this case, in this context, I'm going to create a specification for the scene selector panel based entirely on what I see, based entirely on my experiments and my modeling. And then I'm going to present this spec to the person who wrote the program and go down it, and I'll try to figure out, based on my consistency heuristics, more about those in a minute, whether there's something here that seems like a bug. So I will have a discussion with the developer about the specification that I wrote based on an empirical analysis of what this product actually is. And this is obviously exploratory, highly exploratory testing. The point that I want you to notice about all of this, and I'll fast forward this a little bit. You see it's all happening. Here, I'll stop it right here. The point I want you to notice about all this is the ebb and the flow of the thought process. People keep talking about test cases. Test cases play an almost negligible role in the testing I'm doing right here. And I know those of you who really like test cases might say, well, that's right, because you're in the process of developing your test cases. You haven't developed your test cases yet. Maybe after you've developed your test cases, they'll play a bigger role. Maybe. We'll see about that in a few minutes. But what I want you to notice is that the thinking process of testing is a constantly evolving, critical thinking scientific process. For instance, when I first started testing this thing, what I had on the screen, it said, I know it's hard to see the screen, it said word. I put the content of each scene was just the word. And then when I was moving them around, I realized I can't tell if it's actually changing the order of these scenes. So I better improve my test data in order to improve my experiment so that I can witness what I want to witness. So I changed it to 1, 2, 3. Now I'm using things right now on purpose that are very simple to start with. Later on I'll complicate and naturalize my test data. But right now I'm trying to see signals very clearly. So I'm using a one factor at a time focusing heuristic to simplify the data. One of the things I call it is a simplified data oracle. I simplify my data to make it clearer to me what's happening. Of course, by simplifying my data, I could be missing lots of important problems. I'm not concerned about that right now because what I'm doing first in my strategy of analyzing this product is to come up with a theory of how it might work. Later, I can, in a disconfirmatory way, in the spirit of Popper's conjectures and refutations, I can aggressively attack that theory, that naive theory that I come to by doing this. Now, some people who don't understand testing, they stop at this. They just do some simple thing. They see that it doesn't crash. They see that they saw one thing that they expected, and they declare, it works. I tested it, and it works. And they're not aware that there's a bazillion other possible ways you could have done this, lots of different data. And they're not aware, perhaps, of a fundamental scientific principle, and that is, there is no experiment, there is no test for it works. There's no test for the future, for always. All I know is it hasn't failed yet as far as I can tell. That does not say anything about what's going to happen in the next 2 seconds. It could fail in the next 2 seconds and never work again. So I'm trying to point out all these thought processes going on here. I'm using different text. Then I bring in a tool called PearlClip. There's PearlClip, my little tool that I wrote with Danny Fott, which is a tool designed to create all kinds of different text data and put it into the copy buffer so I can paste it. I create a counter string that's 1,000 characters long. A counter string is a string that counts its own length. Again, I'm using patterned data to help clarify what's really going on. And I watch what happens. I notice that when I use a long string like that, the second line down the scene there, it just has one line in it. Well, before it had 3 lines in it, or 2 or 3 lines. How come it's down to 1 line now? That's an interesting thing. Let's investigate that. So I investigate that, and I found out that if there's a word in the scene that's longer than 48 characters, then the snippet ends. It ends at that 48-character word instead of continuing. Oh, okay, so that's a new thing that I figured out. This is a 38-minute session. It goes on and on. I eventually did about 4 hours of testing on this to achieve the result that I achieved. So here I just tried to tell you about testing and show you about testing, but notice what I skipped over. So many decisions I made that I don't have time to talk to you about. I wanted 90 minutes for this talk. I only get like 50 minutes to say what I'm going to say. It's hopelessly inadequate. If we were pairing together, though, which I'd like to pair with you because you got glasses like mine, it'd be perfect, and you got the beard, we would look great together. It's like the Amish testers or something coming in. We will test your software, English. So it's a good old barn raising, bug raising. So we get together, and we would be stopping each other, and we would be talking about this. We'd say, well, why did you do that? Oh, well, I have this theory about this. And I would go, no, wait, don't move. And you'd go, what? And I'd say, I think I have an idea what. Look, just hit this button right now and see. Oh, it wasn't that. Forget it. Keep on doing what you were doing. So we'd be interrupting each other's flow, and you would be making a theory of why I was doing what I was doing, and I would be making a theory of why you were doing what you're doing, and it would be automatic, and it would be effortless. This is the power of pairing, is you don't have to do things explicitly and talk about explicit rules and protocols because you have such natural working together, and our brains are so tuned to it after billions of years of evolution. What's going on here is that I would submit that every act of testing, of genuine testing, intellectual testing, not just output checking, involves at least these simultaneous layers of behavior and thinking and perception. There's the layer of what the tester thinks the tester is doing, what I thought I was trying to do, and how I put that into words, my narrative, my explanation of testing. Below that, there is my enactment of some specific test idea that is driving what I'm doing. What I think of, you might say, as my test case. Although I prefer the word test idea. I think test idea is a softer, more general, more inclusive way to talk about these things. So I have my specific, test idea that I'm trying to pursue, and then I have my explanation of how I'm trying to pursue it. Then I have my knowledge of the product, which underlies all this. Of course, while I was testing this, I right-clicked and I left-clicked because I know what right-clicking means and I know what left-clicking means. And I have all this knowledge about the platform that I'm automatically using to form my theories. I have my idea of what I'm doing here and what I'm supposed to do versus what other people are supposed to be doing. In this case, I'm doing this testing with the knowledge that I have no particular project, so I had to imagine a context. The context I imagined is I'm one-on-one with the developer. He's somewhere else. I'm his testing expert. And I noticed there's no one's ever tested this systematically, and I want to demonstrate to the developer what testing might be. This was my little imagined context here. And I want to demonstrate to the developer that I'm smart and that he should take me seriously. So that's why I'm going to write a little specification for him. And he's going to say, I hope. He's going to say, oh, James, that was, what I was meaning to write a specification. I was meaning to write a help file for that. And now you've written out all this stuff. This is so helpful. That's what I'm hoping will happen. I know it sounds a little bit like, if you've seen Wicked, that the Wizard and Me song from the beginning of Wicked. And that didn't turn out so well. But that's what I'm thinking. So then my knowledge and skill of testing is also underlying that, and my talents and my temperaments. Now, I'm good at coding. I'm very analytical. I like to do modeling. I'm not so good with the people part of things sometimes. So I'm going to focus on the things that I'm good at. Every tester does that, and I'm going to shy away from things that I don't like. So I tend to avoid things that are repetitive. Other people seek things that are repetitive. If it's important to do something repetitive, I'm not going to be so good at it. So all of these things are going on in every act of testing, all these different layers. And my point is, not one of these things can be turned into a program. It cannot be encoded. It is a performance that must be enacted but cannot be encoded. No manager can look at this and say, oh, that looks good. Just turn that into a procedure that we can give to anybody. No, I'm not going to do that. And by the way, if I could do that, then the very next thing you should worry about is someone would encode your job and turn it into a procedure, so we wouldn't need executives at this company anymore. It'd just be little software projects running instead of people running companies. So where's the testing here? Is it the process of learning the scene panel, the actual text that I created to exercise it? Are those test cases? You can't locate the testing in any physical thing you can identify, although, of course, all of those things comprise bits and pieces of the testing. As I analyzed my process, because I recorded this, obviously, and then I looked at the recording and thought carefully about what I did, which is not normally what I do. As I do this, I made this list of important processes, And I'm going to zoom in on this list so you can see it a little bit better. But the first thing on the list is a Levy flight heuristic. That was one of the things that I used. And I'm sure nobody here has ever heard of a Levy flight. And if I'm wrong about that, I'll put my hat on and then I will take it off again to you. I only heard about Levy flights a month ago from a student in Australia who said, well, have you heard of Levy flights? I think you're talking about Levy flights. And I was on Wikipedia like a shot. That's a Levy flight, that weird shape. It's called a Levy flight. A Levy flight is a mathematical object that represents how animals forage for food in a sparse food environment, including humans. Humans also exhibit the properties of a Levy flight. A Levy flight is a special kind of random walk where there's a high probability of taking long walks in a certain direction and then stopping and doing a bunch of short walks. And it turns out that there's a certain optimality of searching for something in a sparse area by doing Levy flights. So when I say the Levy flight heuristic, what I mean is part of how I test, and I bet part of how you test too, is I stop in a place and I look very carefully at that and I just add one character and subtract one character and try to figure out what exactly is happening with copy and paste. And then after about 20 minutes I go, I'm too deep, and I haven't found any juicy stuff. I better get going and test some other stuff. So I run for a distance, doing stuff, looking really quickly, and then I settle down and look at something carefully again. And I'm doing this of sampling carefully in a space, covering it carefully, and then moving to a very different kind of testing or a different kind of part of the product and then testing. And I realized that has the properties of a Levy flight, and probably my instinct to do that is similar to the instinct that tells a shark, maybe we should head 50 miles that way and then look for food again. You know, it's a similar, I suspect, I don't know for sure, it's my theory, it's my conjecture, that's a similar dynamic working in me. So this is a new thought for me, I'm playing with it. I propose, but I don't know, that I was using the Levy flight heuristic here. I use branching and backtracking because first I had an empty text and then I looked and saw everything I could do with the scene selector. Then I put one word in so I have one scene, and then I look at everything I can do with the scene selector, again going over the same interactions, same basic interactions, and then I put several scenes in and go in and see what I can do with the scene selector because I'm thinking maybe there'll be emerging functionality. So that's branching and backtracking. That's continually going down deep, backing up again, changing the tree, going down deep, backing up, changing the tree, going down deep again. So I'm doing that. I'm doing galumphing. Galumphing is a test technique that involves injecting inert actions, that means actions that shouldn't make any difference, into an established test in order to see if you, surprise, stumble on something that you didn't expect. That's called galumphing. I have a whole talk on galumphing. I used fresh eyes find failure, because when I had my student Michael Mack, who's been through the Perscalis program, which is getting more and more famous, and rightfully so. I don't know if there's a talk about what's happening with Perscalis, but Perscalis is amazing. They're training these amazingly eager, committed people from all kinds of disadvantaged, strange, wonderful backgrounds to be testers. And we've got some Perscalis grads in the audience right here. Well, anyway, Michael Mack has been through Perscalis, and he's been through the rapid testing course and all that. So I've been mentoring him. He's in New York City. So I said, come here, I need to do a talk, and you're going to be my guinea pig. So I had him sit down, and I had him test exactly the thing that I just showed you, and I noticed what he did and what he didn't do, and I got some ideas, and it got my brain juices going, and that's the fresh eyes find failure heuristic. Just get some fresh brain in who's just going to see it differently from you. I use that as a conscious heuristic. I don't just stumble into that. I used to stumble into it, but now I use these things as conscious heuristics as a professional. I set out to do this. I know what I'm doing. So many of you in this room are in different parts of your career, and one part of our career that we spend most of our time in is where we're actually pretty good at our job, but we don't know why we're good at our job. We somehow, when we're faced with a problem, we climb over it, we get through it, and people go, hey, good job. But then we have this feeling like, yeah, but can I ever do it again? Was it a fluke? I don't know why I was good at that. I'm glad I am, but, you know, I mean, on some level, Spider-Man's got to be worried that someday the web's not going to come, you know, or someone who throws 100-mile-an-hour fastballs someday, he's just not going to be able to throw the 100-mile-an-hour fastball, and his mysterious skill will be gone, and everyone lives in fear of the wordless skills that disappear one day, and you don't know the invocation to get them back. So part of developing yourself as a tester is to learn to put words to this stuff so that you can invoke it when you need it. I used product element labeling. As part of my process I'm showing you here, I had to invent labels for things the developer hadn't labeled. I'm calling this a scene selector panel because there's no label for what this actually is. I'm calling the little scene snippets snippets. He didn't call them snippets. I have to give them names so that I can write bug reports and talk about this stuff. So I can talk in detail about each one of these things, and each one of these things relates to the thing that I just showed you. And all of that is where I would locate testing. That's where I would say, see, testing happened. That's what I mean when I say testing. That's just some of what I mean. I ran out of space on the slide. I used my do only one slide heuristic instead of doing what Michael Bolton does and have like 5 slides of this all in 72-point font so that everyone can see it, even those sea urchins that only don't have proto eyes, that don't actually focus, can see it in the back of the room. Whereas I like to keep it all on one slide. You know, we have but here's how I deal with that one here, Michael. You'll see this. Here is the specification that I wrote based on all the testing that I did. So I didn't receive a spec. I wrote the spec, and here it is. What these are claims that I am making. You could say these are conjectures that I am making based on the evidence that I have gathered. Every one of the items on this list is backed up by an experiment that I ran, or more than one experiment that I ran, but any one of them could be wrong, which is why I'm going to go over them with the developer, which I wish I had done by the time I got here, but I haven't gotten to contact him yet. So I'm saying what the scene dividers are. I'm talking about I say scene dividers must be placed at the start of the line. What I mean by that is I tried to take a scene divider and put it in different places inside the scene, not at the start of the line, and I never yet have seen, I have not yet seen that it has recognized that that was a scene divider. It just treated it like regular text. So I conjecture that scene dividers must be placed at the start of the line. What I'm demonstrating when I say these words in this way is that for me, being a professional tester, precise speech is important. I want to say what I mean is that I haven't yet seen it. Now I'm writing these as statements of fact because they're useful to manipulate as statements of fact. But I don't actually think these are statements of fact. This is my current theory of what this product does. So notice that some of them are red. The ones that are red are things that I think are probably bugs. Okay, so the filter operates on the full text of the 3 lines of the scene from which the snippet was produced, regardless of what is shown in the snippet. So you can have 3 lines that have too much text, so the snippet can't hold it. But if you filter, it'll filter on those full 3 lines and nothing else in the scene. I think it's weird that the filter doesn't operate on every single word, every single bit of text in the entire scene. I don't know why it would just be the first 3 lines. So that is inconsistent with user expectation to me. It's inconsistent with my imagined purpose of the filtering. It's inconsistent with the product itself because the snippet has less text than that, and if you want it to be fully consistent with the product, then you should be filtering just on what's visible in the snippet, but it's beyond that. So I think it's probably a bug. I'm ready to talk about that, but maybe the developer will say, give me some reason why. Oh no, the first 3 lines, that's what we do, and we do that on purpose because all writers know that if you want to filter on your scenes, of course you're going to put the the tags in the first 3 lines of your scene. That's just obvious. Maybe that's what he's going to tell me. I don't know. So this is all that I have learned. I've got a total of 18 facts that I thought were interesting to write about this based on my testing. Now, what I'm pointing out is that, look, you see this? This is a real thing. I've created this text. This text represents ideas that I believe to some degree, to some reasonable degree. I have evidence for these things being facts. So you might be tempted to say, well, that's the testing. Thank you, James. We have no further need of you. And then flush me down into the Shark Tank, you know? You have done the testing. We have the goods. We don't need you anymore. But of course, this is the result of testing, but it's a work in progress. There may be many more bugs, much more coverage that I haven't gotten to yet. It's a work in progress. And my oracles, my decisions about, is this a bug, is this not a bug, begin from a wordless place where I look at something and I say, this looks wrong. And then I ask myself, why does it feel wrong to me? And I try to put that into words. So we move from the tacit world to the explicit. Pramila was wondering the other day, why do I have so much content on my slides and then I don't talk about all the content and all that? So here's my theory. I have lots more content on my slides than I can talk about because I figure that you might look at this later, you might have questions. I want to give you some material for open season. And some people I figure are more like to read than to listen, and maybe you'll get something new and special out of this. So that's what I was thinking. Now, as a result of this, I came to something close to a test case, or close to a set of test cases, which is I constructed a carefully designed file, which you see here. And this file is designed to facilitate an experiment in filtering in the scene selector panel. So what I've created is a program that produces any number of sections that I want, and then for each section it produces a bunch of subsections for that. If my thing works here, we'll see if it actually works. Let's see if it's going to load. Oh, there it is. Okay. So here we have all these scenes. Okay, and I've used the scene divider text is called section. Now what I want to do is test the filter. Now these scenes, all these sections here are randomly ordered. They're in any order, except that within one major kind of section, all its subsections are in numeric order. So what I'm saying is that here it starts out with section 100.01, and the next one is section 90.01, and oh wait, am I filtering here? Yes, that's right. 100, 90, 79, 25. You notice that those numbers are more or less random, right? They're in random order. But they all start with 01. And how that helps me test is that what I can do is say, well, show me section 25. And I filter for section 25 by going to 5 period. Now what I can do is I know from the design of my special data file here that there should be exactly 25 subsections, and they must be ordered from 1 to 25. This way I can check to see that the filter was correct, that everything I'm expecting is here, and nothing I'm not expecting is here. So I can count these. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 21, 25. Seems to be no problem here. I'm so reluctant to say pass. Instead, I'd rather say, I don't yet see a problem here. As far as I know, apparently. So I can use this, and I can come up with lots of different little things to do. I can say, well, what if I go dot 25 instead of 25 dot? Well, now it's going to find the 25th subsection of every one of the 100 sections, so I guess I'm expecting to see 100 things in this list. And I haven't counted them exactly, but looks like it's plausible that there could be 100 things in this list. And I found out accidentally that when I have a filter activated, I can't move the scenes around. Only when I deactivate a filter can I move the scenes around. I just did that accidentally. I learned that accidentally. Now I can move them after playing with this file. Now notice what's in the top of this file. It says this file consists of, this is an old version of the slide. This file consists of 50 sections. Each section consists of a number of subsections that occurs a number of times equal to the ordinal value of that section. Notice that under that it says test ideas. This is a message to the future tester. Set various divider text strings, filter for sections and subsections, move sections, use replace to change text in interesting ways. Sometimes people say, James, you do all that exploratory testing. Well, what happens when you leave the project? I leave this behind. Does it tell people exactly what to do? Of course not. If I gave something that told them exactly what to do, and I have a lot of experience with this, they would do it, which is the last thing I want from a tester, is to just follow instructions slavishly that I gave you, because that's not intellectually engaging, because that misses lots of potential coverage. So what I'm going to do is I'm going to help them. I've done some careful development of some test data here. I've done some development of test ideas. I want to give them a boost. I want to give them something to work with so that when they come back for regression, they can quickly retest the filtering thing if the filtering thing ever changes. Now, why don't I just automate all this stuff? Because it's very expensive to create, to maintain, and is unnecessary. It only takes a few minutes interacting with this stuff with my brain turned on to get everything that I need out of this. That would be my answer to this. Here's the source code I wrote that generates that file. I give this source code, of course, to the tester. You can't read that, but I wanted to put it all on the thing just so you know it's there. And the tester, if they want to, can edit the source code, make a different kind of file. I intentionally put into variables the pre-text and the post-text and the number of sections and the section divider text so that they can change all those things, rerun the program, and end up with a more interesting data file for themselves that they can do richer and better testing with. So let me get down to brass tacks. What is a test case? There's lots of definitions out there. I think they all amount to mostly this: a set of ideas, instructions, or data for testing some part of a product in some way. Every definition is getting at that. Now, I used the definition for years, which I have abandoned because I no longer think it's important, which is, I used to say a test case is an instance or variation of a test or test idea. And I mean, I think that's fine to have that as a definition. I just don't find anymore that test cases are something that we need to talk about in rapid software testing methodology. Michael has led the charge on this, actually. Every time I talk about test cases, he says, I just don't even need to talk about them anymore. I don't mention them in class. And then I realized, I don't talk about them in class either. I spent 3 days teaching people about rapid software testing, and we just don't use the word test case. We don't find it. It's not that we've banned it. It's not like test automation, which I no longer say test automation. I will not use those words except to make fun of people who say test automation. I don't believe that testing can be automated, and I think it's toxic for us to say test automation. I know I said it for years, but people also smoke for years and then quit smoking too, so give me a break. I've come to believe that the term test automation is toxic and it hurts people, and it won't kill you immediately, but I think you should quit smoking, and I think you should not say test automation. But I'm not saying you shouldn't say test cases. I'm just saying that in the rapid testing methodology, Michael Bolton, Paul Holland, and I'm actually speaking for Paul because I haven't talked to Paul about this yet, so I don't know if he's on board with this yet, but he's the third guy who works with rapid software testing. We just find that we can talk about models, ideas, techniques, heuristics, all these other things, and we don't actually need to say test cases most of the time. So it's not that we've banned it, it's that we've realized it's become a really unimportant part of our work at this point. Because testing cannot be encoded, and test cases keeps kind of implying that oh, the testing is inside the test case. Well, it's not. The funny thing is, even people who are coders for a living do not believe that their work can be encoded. Programmers do not sit around thinking, but how can we write a program that would be a programmer? Let's write a program that will replace ourselves, gentlemen. Like, no programmer is thinking that. And no manager is saying, when are we going to get auto programmers to replace these programmers? I'm so tired of these programmers. And here's how you know I'm right. Go to any programmer and say, are you a manual or an automated programmer? And they will laugh at you. Because they know that programming cannot be automated. If it's automated, there's a trick they do. They change the name of it to compiling or the build process. And then the human rises to the top. The human doesn't get buried underneath all the tools. The human programmer simply becomes a higher level programmer. That's what they say. I used to do 6502 assembly language programming, and I had to worry about the offsets of my relative jumps. I don't worry about that. I didn't worry about that once I started using an assembler. And then I had to manage my memory. Well, now that I use Perl, magic elves manage my memory. I don't know how memory gets managed. I don't ask questions. I just run Perl, and the elves make everything happen, I assume, at night when I'm asleep. So coding is not encoded. People don't have coding cases that they follow the scripts of to write code. You can say, oh, well, but there are coding standards. Yes, sure. There's coding standards, various procedures, absolutely. But no one is going to say that's what programming is. You don't need to learn coding. Just follow all the instructions I give you, and the program will write itself. Nobody believes that. Management doesn't believe that management cases are needed to drive management. People who drive cars don't say, but how will I know when to turn left? Well, I'll give you instructions. I say turn left at the stop sign. But where exactly? And what if something's in the way? What do I do then? Well, I'm not going to write out instructions for that. You're going to learn to drive, and it's all going to work out. Believe me. This is all related to tacit and explicit knowledge. And all I'm going to say is that tacit knowledge is knowledge that is not or cannot be represented as a string of bits. And testing is full of tacit knowledge. And the way I like to think about it is this. This is how I talk about it in my class. What real testing ability is cannot be spoken. It is tacit knowledge, which is just like crab traps put into the ocean to catch crabs. You can't see them, but they're there. What you can see are the buoys. The buoys aren't catching any crabs, but they mark the place of the crab trap. The buoys represent the words we use to talk about testing. And the crab pots represent the actual ability to test. How do I teach a skill that has no words to it? Through example, through shared experiences, through making you struggle with problems. When you struggle with a problem, your brain automatically grows. This is also how you get fitter in your muscles. You don't talk to your muscles and say, so here are the enzymes I'd like you to produce. Okay, this is kind of hard to pronounce, so try to listen carefully, muscles. No, you give your muscles some hard stuff to do, and they get the point that you want to make. Please grow now. Okay, they get the signal. Okay, we're going to grow now. So when I'm teaching testing, when we are exploring testing, we need to get into the real stuff, the wordless stuff of testing, but we need to struggle also and apply some words to that. And when we don't do a good job of connecting the words to that tacit knowledge, what we get is the ISTQB. In other words, people who say, I know, I'll just have all these buoys and I won't bother to buy any of the crab traps and I'll just throw them on the water, and people will say, oh, you're quite the fisherman. And then the buoys just drift away. They drift away. and wash up on some shore. And I'm like, what? Where are my crab? I've got lots of buoys. That's what they told me. They said that the crab fishermen inspectors would look at your buoys and give you a certification. So I got the buoys. Aren't they nice? So we got to deal with both sides of it. We have all of this thinking that goes on, and I've run out of time, so I have to. We're going to go do open season. You can ask questions. So I'm going to end my talk right in the very next slide here, because I want to make a really important point. Yes, it is true that I can do all this test exploration and design work, and then I can write some wonderful code that does fact checking, that does output checking, and that has some value. In fact, it may have a lot of value. In a low-risk situation, such as typically exists for regression testing, which is typically low risk, in other words, typically you don't have new bugs inserted in old stuff every time you touch the code. I mean, it does happen in some technologies at some times, yes, but it isn't normal for programmers to go, I see the tester has tested that. I shall now secretly inject new bugs into what they have tested to fool them. They'll never realize the last place they would look is a place they've already tested. Ha ha ha. You know, developers aren't doing that. Actually, if this scene selector thing works pretty well right now, it'll probably stay working. Yes, it's possible that it will break. Yes, that's possible, and I do need to go back and take a look at it. But it's not like I go to DEF CON 4 every time the code is touched and say, I must redo all the testing on scene selector. You know, winged monkeys, you fly. In a low-risk situation, it can be perfectly okay to have a whole bunch of automated or semi-automated checks that occur, and that could be enough for you. You may not need deep testing to happen again. That doesn't mean testing has been encoded into those checks. It means that testing is not necessary. That's in a performance culture. What we would say is, if you've got a whole bunch of encoded artifacts, and they're doing things for you, that's part of testing. It's not testing. It's part of testing, the way tires are part of a car. Okay? And maybe you don't need to do deep testing, and maybe that's okay. And this is how I talk to continuous deployment people about this, so that I can say it could be okay that you don't have a lot of testing on your project. But let's be clear what testing actually is. It's that thinking part, just like let's be clear what programming is. It's that thinking part. And let's learn to focus on that. And to do that is difficult because you've got to have experiences and then try to put words on them. And I just showed you, there's a lot of stuff going on in my little test session that I showed you. And I have very little time to talk about it, and people don't have the patience to sit around and wait for me to finish talking about it. So it's hard. But we've got to stop thinking of testing as a thing and start thinking about testing as a performance, like an actor in a play, in order to get management to appreciate what we do. That is the end of my main part of my talk. I shall end it here, and I'm ready to go to open season.
Hello, I'm on number three. Can you hear me? Can you hear me? Okay. All right, guys, we're about to head into open season, so you'll be holding up your green cards momentarily. Just a brief point to mention, we've got a whole stack of folks online watching this live, and we've hit some sort of record here today. We've got in the vicinity of 200 guys online, and girls too. Which is approximately 3 to 4 times the number that we usually get for this. So that's fantastic. Thanks for those folks online. As you all know, we also have a Twitter printer, and to those folks online, if you want to send in a question, you can use our Twitter printer. Just make sure that you include AST News handle in the tweet plus a question mark somewhere. That's at @AST_news. And that will come through the Twitter printer, and we'll get into those. All right, let's roll into open season. So hold up your green cards high.
bunch of them. Can't really see the numbers from over here. You're backlit.
By the way, the folks online are from New Zealand, India, Switzerland, Israel, Netherlands, and Australia. All right, number 210. Hit it off. Thanks, Doug.
Hi, I'm Doug Hoffman. For those of you who don't know, James and I have had some really wonderful discussions in the past. And one point that he and I and Michael have discussed briefly and disagreed on, and I still disagree on, which is why I'm bringing it up, is about test automation. And rather than talking about test automation, I want to talk a little bit about your testing versus programming and how programmers never talk about automating their jobs. They have a different job. They create algorithms to solve problems. What you're talking about is not creating an algorithm to solve a problem. So it's kind of comparing an apple to a rock, to say that because the rock isn't edible, right? It's just not in the same. They're not comparable, and by trying to create that comparison and saying that developers can't automate what they do, so testers can't automate what they do. Well, we're doing different things.
Doug, I've been a programmer professionally for 31 years. They are absolutely comparable, and I am comparing them. And I know what I'm doing about that, and you should know better.
I think you should know better.
Well, let me explain again what's going on here. What I'm comparing is intellectual work. I'm saying in the entire realm of intellectual work, and surely you agree that programming is intellectual work. That intellectual process is not and is never intended to be automated. And when they tried to automate this stuff, they changed the name of that thing. We call them compilers. The thing done by compilers used to be done by humans. It is no longer done by humans. Programmers have risen above that because we need that intellectual process of programming. The fact that we create algorithms as programmers is irrelevant. I create algorithms actually as a tester. I'm constantly creating experimental protocols. I'm deciding what to do now, what to do later, the logic of that. We are all creating algorithms. What programmers are doing is encoding algorithms. But encoding algorithms is not the same thing as encoding programming. So look at the nature of their work. The fact that they produce a thing is irrelevant. The thing they produce is not an encoding of their work process. That's the point.
But what we are producing is information of value to other people.
Of course.
And that's not what they're going after.
If that's irrelevant. That's not my point.
That is my point. It's not relevant.
And
your point is not relevant to my point. So you want to talk about your thing, that's fine. My point stands.
And what we're going to do now is we're going to let some other folks have a turn. This is something that's quite common at a conference, is people with passion for the craft get into the arguments. Absolutely fine. Let's continue this argument if we have time at the end, but we'll get through a whole bunch of folks first.
I'll continue it no matter what the next question is. So it's just like those shows where the politicians come on and...
All right, let's
This is
head
a
over.
very important point, and it shouldn't be foreshortened.
And let's carry on this point through other folks. Same thread, injection, number 81, thanks.
Hey, thanks. So I think it's useful in a conversation like this to decompose testing a little bit. And there's lots of ways to do it. You've done some. I think for this context, I like to think about, okay, testing. One way to think about it is I start out by coming up with a mental model of the software under test. I design some tests that I'm going to do. I execute those tests. I analyze the results. I report the results. And of those 5 things, I think I would be silly to try to automate creating a mental model or the test design or the analyzing of the results or the reporting of the results. But the test execution sometimes makes sense to automate. And that test execution is not the testing. And people often say, okay, I have test execution that I've automated. That was the testing. It's not. But I think that to take that test automation or take that test execution, automate it, have that there, and then, so I've created lots of automated checks. I go and I check them on a regular basis. I say, oh, look, okay, these are the things that are green, these are the things that are red. I'm going to drill in to understand the things that are red. That, to me, seems like part of testing. I didn't happen to execute anything with my fingers, but again, the fingers aren't relevant. It's, that still is part of testing, right? It's part of testing if I include it in a process of thinking about the software under test, analyzing it, reporting results.
If you, in any walk of life, if you do something and you use a tool, the tool is part of your process. You can walk around with a video camera glued to your eyes, maybe something like Google Glass for that matter, okay? And the Google Glass could be doing something special to the image. And it's tinting the image in a certain way, it's highlighting certain things. Okay, that's part of your process, but it still is you are reacting to what's happening. You are making decisions about what's happening. The process is you plus your tool. I wear glasses, so everything I see filters through my glasses. I don't say that my glasses are somehow automating my testing because they're receiving all the light from the screen before my eyes do and processing it. The important thing is not that I'm looking at it through glasses. The important thing is my mind is operating. That's where the testing is. This is why I draw a parallel, and it's an absolutely correct parallel between testing and every single other intellectual thing that can't be automated in the entire world, including parenting, including courtship, including all kinds of things that we don't have apps for, okay?
Wait on. You can't talk without a mic.
I think the thing that gets confusing is there's a piece of it that is commonly automated. And I think it's useful rather than sort of, can it be automated, can it not be, to say, oh, there's a particular piece of it that's automated. Is that the most interesting piece?
I say instead of test automation.
Test execution is not necessarily the most interesting piece of testing. In some ways, it's the least interesting. But it's a piece of it.
Right, so I just think we should change your language. I think we should say automation in testing or tool-supported testing. Or, I use terms that I try to avoid the toxic ideas. You just said, well, I create a test and then I execute the test. I don't actually speak that way anymore because that makes it seem like the test is now encapsulated. Instead, I say, I perform testing. As if imagine a writer of a play saying, I write the play and then my play is executed. That's not how they actually think about plays. Your play is performed.
I think the place where it's useful to decompose it into pieces is when there's one piece that makes sense to automate and there's other pieces that don't make sense to automate. I think that the reason that I decomposed it initially into modeling, design, execution, analysis was not because that's the way that I think it through necessarily when I'm doing it, but because it was a useful way to talk about what parts make sense to consider automating and what parts don't make sense.
And I don't have any strong objection to what you said. I'm just pointing out that as I get older and I work very hard on this, I'm getting very specific about my language because these tiny little distinctions I find actually matter. And so I have a big objection to what you say, but I would prefer to say instead of execute a test, I perform the test. Okay,
let's leave that one there. So what we've got is a situation where we've got folks that want to get into some debate, and we don't have time. We've got about 10 or so on the stack. We've got lots of people that want to get their questions up. So we'll strike out, write a reply. It's just question only from here on in. Where'd we get to? Over here. You struck it? Michael Bolton.
Thank you. I just tweeted something that programmers don't encode algorithms to solve problems. Programmers encode algorithms to mediate the aspects of work of people who solve problems. Aspects of the work of people, portions of the work of people. What programmers are doing is they are writing programs that mediate the work. The program doesn't solve a problem. The computer program helps a person to solve a problem. In the same way, tools and automation in testing do not replace the testing. They mediate some of the work of the tester, the work that can be mediated. The difference being rooted in the last thing you said, James, about the difference between tacit and explicit knowledge. The difference between testing and checking, the difference between testing and using tools to mediate testing is exactly cut along the lines between tacit and explicit knowledge, between knowledge that can be encoded, knowledge that can be made explicit, and knowledge that, so far as we know, because it is grounded in social interactions, cannot be encoded.
Can you cite Harry Collins'
Harry
book?
Collins, Tacit and Explicit Knowledge, Harry Collins, The Shape of Actions. Those two
books profoundly influenced
James
Michael
and me.
I. Yes. Our professional lives were changed when I read Shape of Actions and didn't realize how important it was. Then he read it and realized how important it was. And then we both read Tacit and Explicit Knowledge, and we suddenly saw clearly what we had only dimly guessed at. And I would recommend Harry Collins, the work of Harry Collins, to everyone here. He's a sociologist who studies scientists.
Okay, thank you. Number 232, thanks. Same thread.
Hi, I'm JCD. So I'm kind of wondering, when you talk about programmers not doing automation, what is refactoring then? What is the IDE which we have? Not the compiler. I'll agree that compiling is a form of automation, but isn't refactoring kind of their form of using something of a tool-assisted way of changing your code? Yeah, there's the intellectual piece. They have to know what to refactor. But isn't that also an automated piece? In the same way that when I write an automated test, which does checking, which I'm okay with, but when I'm writing it, I'm using my intellect to write it. So I'm wondering how...
If I had Martin Fowler here and said, Martin, when you talked about, I think he was the first guy to talk about refactoring in a big way. When you talked about refactoring, did you mean an algorithmic turn-the-crank process that anyone could do with no skill at all as long as they had the right tool? He would go, no. No. Who says that? That's crazy. This is a skilled human process. Agile is all about skilled people working together, from the Agile Manifesto on. Of course we use tools to help us. I use tools to help me all the time. You saw, I mean, I wrote code to create the test data file, and I don't feel bad or wrong for doing that. I'm just saying that the code is not testing. The code is a tool I use to, as Michael said, mediate my testing. It helps me do things. The hammer is not the skill of the carpenter. The carpenter must use the hammer skillfully. So yes, we use tools, and the tools help us. But I would look, if I'm training you to do refactoring, I don't say, are you using this tool? And you go, yes. And I go, well, my work here is done. I would say, okay, now let me watch you do this, and let me comment on what you're doing and how you're doing it, and what kinds of decisions you're making about refactoring.
So you'd call that a performance then?
It is absolutely performance.
So that would be testing. So I'm doing automated testing when I'm doing the writing, not doing the running.
You're not automating your testing. You're automating actions that check facts. And you can do automated output checking. You absolutely can. But output checking, testing is so much more than output checking. Testing is all the judgment and all the analysis and all the feelings around that.
Even better response. Okay, so we're going to go to a tweeter printer question now. And this is from Vianchak, or Vianchak, or V-I-A-N-Chak. James, how do you track your testing progress during rapid testing, and how do you track coverage by tests?
Coverage by tests?
Feel free to interpret.
This is a very common question. Michael, Paul, and I get this question every class. It's like one of the big 8 questions that we get, along with how do you quantify the value of testing? What do you do when a tester leaves? To answer this question would take too long to do deeply, so I'm going to answer it in a really, really quick way. I'm going to say I track it by often using creating a mind map. That's one way. That's called thread-based test management. I develop a mind map with test ideas, and then I walk through the mind map, and I look at what I've done, and I evaluate that, and I talk to other people about it. It's a human process. And if you actually know how to test, then you find that this human process is not particularly difficult to do. But you have to learn how to test. You have to learn how to talk about testing, and that's a skill.
Thank you. We've actually canned the same threads on the first thread. Sorry for those folks, but we will move along. We've got a new thread, number 42.
Hi. So what I'm hearing in the general discussion is really something from linguistics. Saussure defined 2 types of expression. The parole, which is just the utterance of the word, which I hear everybody using. Test, 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 testing, test, test. And then there's the lang, which is the abstract concept behind the role. And that's where I think this disagreement that I'm kind of noticing is happening, in that we're all using the same word, but I don't know that there's, I do know that there's a big disagreement on what that term encapsulates, and I think that it might be worth it just to, for me, it's been worth it to think about how we're using this word, how we're using the word test, because when we put the word test automation together, when we put those words together, if we're referring to test in the RST course, James, Michael, Paul, kind of a way that we're referring to test, we're really talking about that activity, that performance of testing. And we're talking about automation as a form of checking, if I'm understanding correctly what I'm hearing. So I think that definition of test, as it is understood in that particular practice, might be different from the way other people are using the word test. And so I propose in my thread that we possibly, as testers, look into other disciplines like linguistics, performance arts. I have violinist and a violist, so for me these really inform the ways that I'm thinking about that, and try to realize that I think we all want the same thing. We all want to test well, and well is another contestable term, but we all want to do that. And so thinking about how these other disciplines can inform our abstract definitions.
This is why I love social scientists. This is because you're willing to go deeper. And that's what we need to do to solve this problem. Our craft is in perpetual childhood because people refuse to go deeper. They don't want to have conversations and arguments. We need to have the conversations. We need to have the arguments. Where my crew is proposing what we think is a much better, much more powerful ontology of software testing. And if you're the kind of person who doesn't like to learn what words like ontology means, then that's okay. But I think you're limiting yourselves as experts in the craft by not examining that. Now, you're a social scientist, I happen to know. And I appreciate you bringing that into this room. This is exactly what I think we need to do.
Okay, thank you. We've got time just for one more question. New thread. Where did he go? There he is, 145.
Yeah. What's the one thing you would stress to someone new to the field?
Someone new to the field?
Yeah.
The first thing I would stress to someone very new to the field is you need to practice testing. You need experiences. Don't worry about the words for now. For now, I am just going to put you in front of a product, and I'm going to give you a challenge. And the challenge is find something wrong with the thing in front of you any way you can. I'll give you some scattered facts about it, and then go and try to find something interesting and possibly wrong about it. Play, explore, and then what I do, this is exactly how you train a dog, by the way. How you train a dog is you don't explain to the dog, now let me tell you what sitting is. Let me tell you the sitting procedure. The dogs just go, brr, you know. What you do is the dog behaves in a certain way, and the dog notices that when he behaves in a certain way, you go, here's some treat. And the dog goes, oh, I get it. So if I do that, I'm going to get the good stuff. Well, I think I'm going to do more of that. So what I do is I get new people doing stuff, and then when they do stuff really interesting, I might say, oh, cool, look at that thing you invented, this method. You know, that has a name. We call that equivalence class partitioning. I know it's a fancy name, but you just invented the technique without even knowing about it. You're some kind of testing genius. And they go, oh, wow, maybe I have talent for this. And then that makes them want to learn more. For people who are experienced, who are not new to the field, those are the people I look at and say, learn to talk. Learn to care about these distinctions. But when you're new, don't worry about the distinctions very much. You need experiences.